What if the internet had its own co-pilot? Not for a plane or a car, but for that huge, invisible network that connects basically everything in our lives. Well, today we're going to dig into a really fascinating new AI that's designed to do exactly that. I want you to just imagine for a second a world where those massive network outages that grind businesses to a halt or just ruin your movie night are prevented before they even start. A system that can spot the absolute faintest warning signs of a problem and fix it proactively. That's the big idea we're tackling today.
All right, so here's our game plan. First, we'll talk about a hidden danger that's lurking in our networks right now. Then, we'll get into why the first attempts to use AI for this failed. It's called the black box problem. After that, we'll break down a brand new 4-part AI solution that actually works. We'll look at the proof, the hard numbers, and then wrap up by talking about what it really means to build AI that we can genuinely trust.
Okay, so let's jump right in and understand the problem we're trying to solve. It's this quiet, invisible threat that's working away just beneath the surface of our digital world.
You've got to think of the global internet like a massive system of superhighways. These are what we call elastic optical networks, or EONs, and they carry everything, your video calls, your online banking, all of it, as pulses of light. They're the absolute backbone of all modern communication.
Now, the villain in our story is something called a soft failure, and this is where things get tricky. See, unlike a sudden network crash that blares alarms everywhere, a soft failure is this slow, creeping decay in the network's health. It's so sneaky because it happens without anyone really noticing, kind of like a slow leak in a tire. Everything seems fine until suddenly it's not.
Okay, so what are these slow leaks really? Well, they're things with these super technical names like filter passband narrowing or a drift in the center frequency. But you don't need to be a network engineer to get the main point. The bottom line is all these little issues slowly mess with the signal quality, or what the pros call quality of transmission. Your connection just gets worse and worse and you don't even know why.
So the obvious solution, right? Just throw some AI at the problem. Well, people tried that, but they hit a massive wall, and it's called the black box problem.
And here's the deal. The early AI models, yeah, they could predict that a failure might be coming, but, and this is a huge but, you couldn't trust them. The probabilities they gave were all over the place, they had no way of explaining why they were making a prediction, and there was zero control over the risk involved. Now, if you're a network operator responsible for critical infrastructure, that's a total non-starter. You can't run the internet on a maybe. You need real confidence, clear reasons, and solid guarantees. So, how do you bridge that gap? How do you solve that trust problem? The answer, it turns out, is a new, really clever 4-part AI solution that was designed from the ground up to build that missing trust.
And this whole framework is just beautifully simple in its design. It's a toolkit with 4 crucial jobs. First, you predict what's going to happen. Second, you calibrate how confident you are in that prediction. Third, you guarantee your performance. And fourth, the big one, you explain your reasoning. Let's walk through each one.
Step 1 is all about prediction. This is the brain of the whole operation. It uses these really powerful AI models, GRU and LSTM if you're curious, that are great at spotting patterns over time. They chew through 24 days of network history, learn what trouble looks like, and then use that to forecast potential soft failures up to 3 days before they actually cause a problem.
Okay, but a raw prediction is pretty useless if you don't know how much to trust it, right? That's where calibration comes in. The system uses a clever technique to make sure that when the AI says it's, say, 90% confident, it's actually right 90% of the time. This turns what could be a wild guess into a truly reliable probability. Now, this next step is a real game changer. It's the guarantee. Using a method called conformal prediction, the AI is actually smart enough to know what it doesn't know. If a situation is too fuzzy or uncertain, it simply says, hey, I'm sitting this one out, and it abstains from making a prediction. This gives the human operators real mathematical control over the level of risk they're willing to accept.
And finally, the step that solves that whole black box nightmare we talked about, explainability. Using something called Explainable AI, the system is no longer a mystery. It can literally lift the hood and show its work, pointing to the exact data, those specific slow leaks that led it to raise a red flag. That's how you build real human trust.
So, the theory sounds amazing, right? A trustworthy AI co-pilot. But does it actually work in the real world? Well, let's look at the numbers, because they do not lie.
First up, accuracy. The system scored a 0.985 on what's called an AUC score. To put that in perspective, a perfect score is 1.0,
So this is incredibly close to perfect. It means the model is just exceptionally good at telling the difference between a healthy network and one that's about to have a problem.
And what about that guarantee we talked about? Well, the framework can be set to provide 95% coverage. That means it's making a confident, reliable call on 95% of all situations, only stepping back on the absolute murkiest cases. That gives operators a huge, trustworthy field of vision.
And for those calls it does make, the ones within that 95% coverage, get this. The error rate is less than 5%. Just think about that for a second. When this system makes a prediction, it is right more than 19 times out of 20. That is the kind of rock-solid reliability you can build an entire proactive maintenance strategy on.
But this right here, this might be my favorite part. This shows us that the AI isn't just finding some weird random correlations in the data. When the researchers asked it to explain its decisions, it consistently pointed to filter bandwidth as the #1 culprit. That's the exact same thing a human network physicist would look for. It proves the AI actually learned the real-world physics behind these failures.
Okay, so let's zoom out for a minute, because this is about so much more than just keeping our Wi-Fi running smoothly. This is really about a whole new way of thinking, a new blueprint for building AI that we can actually trust with our most critical systems.
This slide just sums it up perfectly. We are making a fundamental shift. The old way was an AI that just gave you a prediction, basically a highly educated guess. This new framework gives you a trustworthy decision. It's a recommendation that's reliable, where the risk is managed, and the reasoning is totally transparent. That is a massive leap forward.
Honestly, the researchers themselves put it best. They described a system that delivers trustworthy prediction with calibrated probabilities, formal guarantees, and physics-consistent explanations. It's not just one piece of the puzzle, it's the whole shebang, a complete toolkit for intelligent, proactive network maintenance.
And all of this leaves us with one final, really important question. If the next big frontier for AI isn't just about making it smarter, but about making it trustworthy, where do you think we need that the most? In our power grids? In medicine? Our financial markets? The possibilities are absolutely profound. Thanks so much for diving into this with me.